Dear learners, welcome to the new lecture of the lecture series of engineering chemistry. In today's video, we will cover the following topics: determination of water hardness. In this, we will cover the types of determination methods. And this determination method types, we will cover the topic Clark's method in detail, which includes principle, procedure, and calculations of the Clark's method. So let us begin. So how can water hardness can be determined? So we know that hardness of water is caused by the presence of calcium and magnesium ions in the water. So if we want to determine the hardness of water, we have to calculate the amount of calcium and magnesium ions present in the water. So in other way, we can say that hardness of water can be determined by the amount of calcium and magnesium ions present in the water. So by calculating the amount of calcium and magnesium ions in the water, we can determine the hardness of the water. And this hardness can be determined by two types of method. These methods are the Clark method, which is also known as the soap titration method. Second one is the complexometric titration method, which is known as the EDTA method. In today's video, we will discuss in detail the Clark's method. The principle of Clark's method includes the titration of water sample with the soap solution. So we know that the calcium and magnesium ion present in the hard water reacts with the soap, soap, and this soap after reaction with calcium or magnesium ion is formed the scum, that is the calcium salt of the soap. So when soap solution is added to hard water, the hardness causing ion present in the hard water sample, that is calcium and magnesium ion, reacts to react with soap. Therefore, the soap is not available to form the lather. So lather is not formed when we add the soap solution to the hard water. Why? Because the hardness causing ion forms the scum with the soap solution. When all the calcium and magnesium ion present in the hard water get consumed with the soap solution, then after this when we add it when we add the after this when we add the soap solution, then it will create the lather with the hard water. Why? Because all the calcium and magnesium ions get consumed to form the scum, then the remaining water does not contain the calcium and magnesium ions. Therefore, now this water can form lather with the soap solution. So it is very clear that the amount of calcium and magnesium ion present in the hard water sample is directly proportional to the volume of soap solution used for the titration. Therefore, we can determine the hardness by estimating the volume of the soap solution get consumed during the titration. One important point in this titration, that no indicator is used in this titration, because the endpoint of this titration is the formation of persistent lather with the soap. So persistent lather means lather formation, the lather at which is stable up to 2 minutes at least, which indicates that the all calcium and magnesium ion get consumed to form the scum. So no hardness is remaining in the water sample. So this indicates that this is the endpoint of the titration. So after that, it concluded that when we titrated the hard water sample with the soap solution reacts with the calcium and magnesium ion present in the solution. That means the hardness present in the solution, and then all the hardness consuming ion get consumed. Then this water sample form the leather with the soap. So after all consumption of the hardness causing ions, there will be the formation of the leather. That is the endpoint of the titration. So now coming towards the procedure parts, the procedure includes 5 steps. These 5 steps are preparation of standard hard water, then standardization of soap solution, then determination of leather factor, and determination of total hardness, and last one is the determination of the permanent hardness. So we will discuss all these steps one by one. So first is the preparation of the standard hard water. To prepare the standard hard water, what is the meaning of the standard hard water here? The standard hard water is the solution of the calcium carbonate. But we know that the calcium carbonate is the most insoluble salt in the water. So when it is the most insoluble salt in the water, so how we prepare the standard hard water? So to prepare the standard hard water, we have to prepare the calcium carbonate solution. So calcium carbonate first dissolve in the minimum amount of hydrochloric acid. Now this solution is evaporated till the dryness to remove the excess of HCl and carbon dioxide. The remaining residue is now dissolved in the distilled water to make the volume of the solution 1 liter. So this is how we prepare the standard hard water. So what is the concentration of standard hard water? It contains 1 milligram calcium carbonate in 1 ml of standard hard water. See here, we dissolve the 1 gram calcium carbonate in 1 liter. So 1 gram in 1 liter, or we can say 1 milligram in 1 ml. So standard hard water concentration is 1 milligram per ml of calcium carbonate. Now the second step of this procedure is standardization of soap solution. So standardization of soap solution includes the titration between standard hard water and the soap solution. So standardization means what? Standardization means we have to know that soaps, each ml of soap solution is equivalent to how much of calcium carbonate equivalent, because we know that the hardness is expressed in terms of calcium carbonate equivalent. So standardization of soap solution gives us the amount of calcium carbonate equivalent of per ml of the soap solution. For this purpose, we have to prepare the soap solution. For this, the 10 gram of pure soap is dissolved in the alcohol and water mixture. In this alcohol and water mixture, the ratio of the alcohol and water is 800 ml alcohol and 200 ml of the water sample. So in this step, second step, standardization of soap solution includes titration of standard hard water with the soap solution. In the conical flask, we are taking the 10 ml of standard hard water and titrated it with the standard soap solution which we have prepared. The endpoint of the titration is the persistent leather formation. So this is the, suppose this reading comes out to be V1 ml. So this is the standardization or the second step of our titration. So first step is the formation of the standard hard water, and second step is the standardization of soap solution. In this standardization method, we are titrating the water standard hard water which we have prepared with the soap solution. Now, third step is the determination of determination of the leather factor. What is the leather factor? Leather factor is determined by the titration of soap solution with the distilled water. See here, we know that the distilled water does not contain any calcium or magnesium or the hardness. So when we titrate the distilled water with the soap solution, there will be the foam leather formation. That means immediately very few drop of addition of the soap solution creates the leather. So what this amount is called? This amount is called as the leather factor. This is necessary to determine the leather factor because we have to know the exact value of the soap volume consumed only due to the hardness. That is why leather factor is determined. For this purpose, we have to titrate the 10 ml of distilled water taken in the conical flask with the soap solution which is taken in the burette. So titration is carried out until the end point. The end point of the titration is the permanent leather formation for at least the 2 minutes. Suppose this time the soap solution consumed is recorded as the VML. So this is known as the leather factor. Now, the next step of this titration is the determination of the total hardness. To determine the total hardness, we titrate the soap solution with the or water sample in which hardness is to be determined. So, soap solution is taken in the burette and in the conical flask, 10 ml of water sample is taken. Titration is carried out with the same procedure till the end point. Suppose this time the reading comes of the soap solution comes out to be the V2 ml. So to determine the total hardness, we have to titrate the water sample with the soap solution. To determine the leather factor, we have to titrate distilled water with the soap solution. And to determine the standardization of the soap solution, we have to titrate standard hard water with the soap solution. Now, final step, that is the determination of the permanent hardness. We know that the total hardness is the complete hardness which includes temporary and the permanent hardness. But when we remove the temporary hardness by boiling of the water, then only the permanent hardness remains in the water sample. So if we calculate the permanent hardness, we have to boil the water first. Why boiling is necessary? Because the boiling removes the temporary hardness. So in this titration, we have to titrate the soap solution with the boiled water sample. Boiled water sample contains only the permanent hardness. That is why we are taking here the boiled water only. In the burette, soap solution is taken and in the conical flask 10 ml of the boiled water is taken. Now titration is carried out in the same way till the end point, that is the permanent leather formation for at least 2 minutes. Suppose this time the reading comes out to be the V3 ml. So now what observations we are having till now? We carried out four titrations, sorry. First is with the standard hard water, second with the distilled water, third with the water sample, and fourth one is with the boiled water sample. So now the observations we have here, we know the strength of the standard hard water is the 1 ml of standard hard water is equal to 1 milligram of calcium carbonate. Second observation we have the volume of the soap solution consumed with standard hard water V1 ml. Volume of the soap solution consumed with the distilled water, this is the leather factor VML. Volume of soap solution consumed with the water sample V2 ml. Volume of soap solution consumed with the boiled water sample, that is the V3 ml. So 4 volume reading we are having here. First is the reading with standard hard water V1. Second, reading with distilled water, that is VML, that is known as the leather factor. Then reading with the water sample, that is V2, and then reading with the boiled water sample, that is V3. So these are the observations we have here. Now to calculate the hardness of the given water sample, we have to learn about how to calculate this hardness. So first step is the standardization of the soap solution. We know that the 1 ml standard hard water contains 1 milligram of calcium carbonate. Now, 10 ml of standard hard water is equal to V1 minus V ml of soap solution. Why we are subtracting the leather factor here? Because when we titrated the standard hard water with the soap solution, the reading volume reading come V1 ml. But to know the exact amount of soap consumed only due to the calcium ions present in the standard hard water, we have to subtract the reading, that is the lather factor, because the lather factor is the reading of the distilled water with the soap solution. So if we want to know only the calcium and magnesium ions consume this soap solution, then we have to subtract the V from the total V1 volume. So V1 minus V soap solution is that amount of soap solution that is only used by the calcium ions present in the standard hard water. So that is why we are here subtracting the lather factor from the volume of the soap solution consumed with the standard hard water, right? So 10 ml of standard hard water is equal to V1 minus VmL of soap solution. So we can write this statement is as V1 minus VmL of soap solution will be equal to 10 ml of standard hard water. Just reverse the solution. 10 ml standard hard water is V1 minus V1 ml of soap solution. That means V1 minus V ml of soap solution is equal to 10 ml of standard hard water. So if V1 minus V ml of soap solution is equal to 10 ml, so 1 ml of soap solution is equal to 10 divided by V1 minus V ml of standard hard water. And we know the strength of standard hard water is 1 ml standard hard water is equal to 1 milligram of calcium carbonate. So that is why we can write here 1 ml of soap solution is equal to 10 divided by V1 minus V milligram of calcium carbonate. So as I mentioned earlier, that standardization of soap solution means the each ml of soap solution is equal to how much amount of calcium carbonate equivalents. So now here we are concluded that 1 ml of soap solution is equal to 10 divided by V1 minus V milligram of calcium carbonate equivalent. So this is the very important terminology we have just derived, that the amount of calcium carbonate equivalent for the each ml of the soap solution. Now coming towards the next part of our calculation, that is determination of total hardness. To determine the total hardness, see here just we have derived that 1 ml of soap solution is equal to 10 divided by V1 minus V milligram of calcium carbonate. And by titration, we know that 10 ml of water sample is equal to V2 ml of soap solution. But here we are using V2 minus VmL of soap solution. Why? Because we want to know the exact amount of soap solution consumed only due to the hardness present in this water sample. That is why we are subtracting the lather factor from the total reading, because we want to know the volume of soap consumed only due to the hardness present in the water. That is why here we are taking that 10 ml of water sample is equal to V2 minus V ml of the soap solution. Now, if V2 minus V ml of soap solution is equal to V2 minus VmL of soap solution is equal to 10 divided by V1 minus V into V2 minus V milligram of calcium carbonate. Why we are putting this equation here? Because we know that 1 ml of soap solution is equal to this much amount of milligram of calcium carbonate. So V2 minus V ml of soap solution is equal to how much milligram of calcium carbonate. So we have to multiply this 1 ml unit by the V2 minus V milligram of calcium carbonate. Therefore, we can write here that 10 ml of water sample is equal to now 10 divided by V2 minus V1 multiplied by V2 minus V milligram of calcium carbonate. So this is the 10 ml of water sample calcium carbonate equivalents. If we want to calculate it for 1 ml of water sample, so we have to divide it by the 10. So this comes out to this 10 cancel out by this 10. So finally this comes out to be 1 minus V divided by V2 minus V. So this is the calcium carbonate equivalent for 1 ml of water sample. But we know that the hardness is calculated in the 1000 ml. So yeah, or parts per billion. That is why in 1000 ml we have to calculate it. So 1000 ml of water sample is equal to V2 minus V divided by V1 minus V. Sorry, this is the V2 and this is the V1. Just a minute. This is V1 and this is V2. So 1000 ml of water sample is equal to V2 minus V divided by V1 minus V into 1000 milligram of calcium carbonate equivalent. Therefore, the total hardness of water sample is equal to V2 minus V by V1 minus V multiplied by 1000 ppm. This is the total hardness of our water sample. Okay, I hope it is very clear to how to derive the formula for total hardness of water present in the water by Clark's method. Now, coming towards the permanent hardness calculation. So, permanent hardness can be determined by titrating the boiled water sample with the soap solution, and we know that this time the reading comes out to be V3 ml. So, begin with the starting that 1 ml of soap solution is equal to 10 divided by V1 minus V milligram of calcium carbonate. And we know that the 10 ml of boiled water sample give the reading V3. So to know the exact amount of soap solution consumed only due to the hardness causing ion present in the boiled water will be equal to V3 minus V. We have to subtract the lather factor here. So the 10 ml of boiled water is equal to V3 minus V ml of the soap solution. And 1 ml of soap solution is equal to this much amount of calcium carbonate. So V3 minus V is equal to 10 divided by V1 minus V multiplied by V3 minus V milligram of calcium carbonate equivalent. So we can write here the 10 ml of boiled water sample is equal to 10 divided by V1 minus V multiplied by V3 minus V milligram of calcium carbonate equivalents. And 1 ml of boiled water sample is equal to 10 divided by V1 minus V multiplied by V3 minus V divided by 10. So this 10 cancel out by this 10. So finally, this 1 ml of boiled water sample is equal to V3 minus V divided by V1 minus V milligram of calcium carbonate equivalents. And 1000 ml of boiled water sample is equal to V3 minus V divided by V1 minus V into 1000. Therefore, we can write here that the permanent hardness is equal to V3 minus V divided by V1 minus V multiplied by 1000. And what is the unit for this? This unit is the parts per million, that is ppm. So the permanent hardness is equal to V3 minus V divided by V1 minus V into 1000 ppm, right? And for the temporary hardness, we know the temporary hardness is equal to total hardness minus permanent hardness. So the temporary hardness is equal to V2 minus V divided by V1 minus V into 1000. That is the total hardness minus V3 minus V divided by V1 minus V into 1000. That is the permanent hardness. So finally, this is the temporary hardness of the given water sample in the ppm. So I hope now it is very clear for all of you that how to calculate the temporary, permanent and the total hardness by the Clark's method. So now time for the learning check. Read out the question coming to your screen. Pause your video and try to figure out the answer. You have collected water sample from two different sources, mountain spring and the municipal supply. Using the soap titration method, you determine that the spring water requires significantly less soap to form a leather than the municipal water. What could be the possible reason for this? Read out all the options. First, the mountain spring water has a higher concentration of calcium and magnesium. Second, the municipal water is likely treated to reduce its hardness. Third, the mountain spring water contains fewer impurities and mineral than the municipal water. And fourth, the municipal water has a higher temperature affecting the soap efficiency. Think about this. Yes, you're right. The option C is the correct answer. The mountain spring water contains fewer impurities and salts than the municipal water. Why? Because it forms less leather. That spring water requires significantly less soap to form the leather. If less soap is required, that means less hardness is present, and that means less concentration or fewer concentration of hardness is present. That is why option C is the correct option. I hope now the concept of the determination of hardness by Clark method is clear to all of you. Unlock more awesome content by hitting the like button and subscribe my channel. Thank you so much.